Many people like to refer to um, ultimate reality as the universe. Uh, Maybe they don't want to use God, the reference of God, maybe not to sound religious or just that they're atheists, and they just refer to the universe. I feel like I got this inspiration recently, I believe from God, to um, to look at that and say, okay, let's look at the universe. What if we look at the qualities of the universe? Then what does that tell us about reality? Like, let's look at the what makes up the universe. What is the nature of just the universe, and what conclusions can we draw about reality and about our place in it? And so I'm going to do a series of videos on lessons from the universe and pull from some of my knowledge of math and physics and so on, to unpack some of the lessons from the universe. I'm going to go to another frame so I can read some of what I wrote. I'm not going to just read it, but I'm going to unpack some of the things. And the first quality of the universe I want to talk about is that the fact that the universe is unimaginably huge. It's so incredibly big, like beyond the ability to even comprehend. Let me just unpack that a bit. We live on a planet that feels quite large, like it takes many hours to go hundreds and hundreds of miles, and we've only gone a fraction of the distance across the planet of our Earth, right? So our Earth like feels pretty big. Like if you've ever stood in front of the mountains, they feel pretty big, and those are just a small fraction of the whole Earth. So there's that. Like just the Earth feels pretty big, and and then we have this moon. Well, and the moon looks like it's kind of close, but it's actually like 240,000 miles away. So it takes many, many hours to fly there at many thousands of miles per hour in a spaceship. So our closest neighbor I just found out is Mercury, not Venus. Anyways, but Mars, a next door planet neighbor, there's been talk about setting up a colony on Mars. We've actually sent probes to Mars, which is an incredible engineering feat to do that. And we'll talk about that another time. And if you fly in a ship at 25,000 miles per hour, pretty fast, right? Way, way, way faster than the speed of sound. Not anywhere close to the speed of light, and we're going to get to that. But 25,000 miles per hour, it takes 7 months, 7 months to get to a next door neighbor of Mars. Okay, so that's like already kind of mind blowing. 7 months, 25,000 miles an hour. Okay, Voyager 2 is one of two space probes that were sent out into space in the 70s. I believe both were in the 70s, to explore our solar system and beyond. They were sent out in, Voyager 2 was sent out in August of 1977. It took Voyager 2 12 years, traveling at the speed of 34,000 miles per hour, 12 years to get to Neptune, which is on the farther reaches of our solar system, which is 3 billion miles from us. So this is just our solar system, right? Like just the planets on around our star, which we call the sun. And that's just our solar system. So many, many years going really fast, 34,000 miles an hour, just to get to the edge of our solar system. And it's not even the edge of our solar system because there's other protoplanets. Pluto was downgraded to a protoplanet. Anyways, so the closest star to our sun is called Proxima Centauri, and it's 4.2 light years away. Now, this is really important because scientists use this term light years quite a bit. A light year is not a unit of time, even though it has the word year in it. It's actually a unit of distance, and it's how far light travels in a year, in an Earth year, 365.25 days, right? So now get this, light travels at 186,000 miles per second. Every second, light can go around the whole planet of the Earth 7 times, more than 7 times. Like go all the way around the Earth 7 times in 1 second. That's how fast light travels, 186,000 miles in 1 second. And yet, the closest star is 4.2 light years, not light seconds, light years. So, Voyager 2, traveling at that speed that I mentioned earlier, 34,000 miles per hour, that's 9.6 miles every second. So very far short of a light year, right? A light year is 180, I'm sorry, light speed is 186,000 miles per second. Voyager 2 is only traveling at 9.6, not 186,000, but 9.6. It would take Voyager 2 at that speed, 34,000 miles per hour, it would take it 19,390 years to travel just one light year. And that closest star, Proxima Centauri, is 4.2 light years away. That's the closest star. 19,000 years at 34,000 miles an hour to go just to the nearest star. What? Okay, so I hope it's starting to blow your mind at how big this universe is. So just a couple more things, well, which will like blow it up even more ridiculously. So that's just our nearest star. When we look in the night sky, we see thousands of stars that are light years away, many of them light years away. Our Milky Way galaxy has 100 to 400 billion stars in it. Stars like our sun, some much bigger, some smaller, but 100 to 400 billion stars in just our Milky Way galaxy. Hard to imagine. Just so you get an idea of this number billion. Billion, we don't really have a good grasp of it so often. There are billionaires, have billions of dollars, whatever. It is an incredibly large amount of stars, just 1 billion. So if you were to try to count to the number billion, just one number a second, 1, 2, 3, 4, 5, 6, and you can say the first number is pretty quick, but once you get to 1,345,652, 1,345,643, whatever it was I stopped at. It takes more than a second to say it, but if you could say every number in 1 second, it would take you 32 years to count to 1 billion. 32 years to count to 1 billion, okay, if you didn't sleep at all for all those 32 years and you 24 hours a day, you were just counting the whole time. Okay, so that's 1 billion. There are hundreds of billions of stars like our sun and solar systems like our solar system in the Milky Way. So that's like mind-blowing. Years and years and years for light to get across it. Our Milky Way, let's see, is 100,000 light years across. So it takes light 100,000 years at 186,000 miles per second to go across just our Milky Way galaxy. And now get this, prepare for your mind to be blown even more. There are 200, they estimate that scientists that there are 200 billion to 2 trillion, that's 2 followed by 12 zeros, galaxies in the visible universe. So our Milky Way already has hundreds of billions of stars, but it's only one of possibly 2 trillion galaxies that each have hundreds of billions of stars, each hundreds of thousands of light years across. Like, it's so mind-blowing how incredibly big this universe is. And so what is our lesson from the universe? Doesn't it seem we're pretty dang small? Like you and I, like this earth, like there's pictures, I think Carl Sagan, there's when we sent out the going out to the moon, and I think they took a picture from one of the probes like Voyager or something back like thousands of millions of miles back looking at Earth, and you could find it was like a pale blue dot. They called it the pale blue dot I think it was just in the solar system looking back. Just from the solar system, we were just this little dot. And then in light of the millions and billions of light years that we're talking about across all of these trillions of galaxies with billions of stars each, the lesson from the universe is, good Lord, we are so small, and shouldn't we have some humility? Don't you think? It seems like the universe is telling us, you don't have much figured out, do you? You're pretty small. Like, if you think you've got this whole thing figured out, you probably don't. Like, humility is very much in order. And and I think that's one of the best lessons that we can get from the universe. So I hope this encouraged you, blessed you, um, and look forward to more videos coming on lessons from the universe.